Alright guys, so in these notes right here we're going to be going over volume of cylinders. We're going to go over how to find volume of cylinders, and we're going to also give you a definition of what makes a shape or what makes an object a cylinder. Okay, so first thing is, before we get going on how to actually find the volume of the cylinder, I think it's a really good idea to talk about what is a cylinder. How do you define a cylinder? Okay, so a cylinder, and this is a loose definition, so once again I did not look this up in Webster's dictionary or anything like this, but a cylinder is a solid three-dimensional object and we could just say 3D if we want to. A solid three-dimensional object that has two congruent and parallel circles or ovals. Okay, so in order for a shape to be a cylinder, we've just told you there's a couple things that have to happen. First of all, it has to be a solid three-dimensional object. So what does that mean? Anything that's three-dimensional means that there's depth to the object. So just like a rectangle is not three-dimensional. So a rectangle cannot be a cylinder, obviously. But that's what three-dimensional means. And then it has to have two congruent and parallel circles or ovals. And you'll find out today that all of the cylinders that we draw, all the cylinders that we work with, always involve circles. We're not going to have any cylinders that involve ovals. Okay, so examples of a cylinder, and you guys see these every day. So if you have ever purchased, let's see, a soda can, and usually in the aluminum form of the soda can or a drink, then that would be, those are typically in the shape of cylinders. Okay, and the way that you draw them is this, or the way that I draw them is that I draw two shapes, and when I draw them they always look like ovals, but they're representing circles. I just want to let you know that it's kind of like a and then it's kind of like a optical illusion a little bit. Put points kind of like in the middle of each side of this. Draw two line segments that go down like this and make the two line segments the same length, and then at the bottom draw another circle or oval that looks like more or less like the one on the top. Okay, and there we go. So that right there would be an example of how you draw a cylinder. This right here would be a cylinder. Now if you notice, why is it a cylinder? Well, by the definition, is this a solid three-dimensional object? Yes, it is. Does it have two congruent and parallel circles or ovals? Yeah. Okay, those two right there. So that circle is congruent to that circle. They're also parallel to each other, and they won't ever, because they won't ever touch. Okay, so there's a couple things that a couple terminology that we need to go over and understand about cylinders is, and this terminology is important because you're going to keep hearing me say these words as we go about finding volume of cylinders. So terminology is, first of all, the bases. So the bases in a cylinder are going to be the two congruent and parallel circles. And once again, they could be ovals, but for this class, we're always going to assume that when we're talking about a cylinder, the bases are circles. Okay? And then the height of the cylinder is going to be any segment that connects the two bases. The two bases. And the two bases, once again, will be the congruent and parallel circles. So when we talk about the height of a cylinder, it has to be a segment. So that right there, that segment would be a height, as would this segment right there. So there are two possibilities for the height of this cylinder, and both of them will be the same, but either one of those would be called the height. As a matter of fact, they both would be called the height. So that segment is considered a height, as is that segment right there. Okay? So there's some basic terminology of a cylinder and what makes a cylinder by the definition. And so now let's go over, how do you find volume of a cylinder? So finding volume of cylinders. Okay, now recall that when you're asked to find volume of any solid object, volume means that when you're finding it, you're figuring out how many cubic units can fit inside this object. Okay, so let's say that I picked up this cylinder here and I filled it with, some object, some solid object like dirt, and I said, man, I wonder how much dirt is inside this cylinder, or how much dirt can this cylinder hold? Well, to answer that question, you'd have to find the volume of the cylinder. And the cool thing is about volume is that there is one formula that will find the volume of every single cylinder, no matter what the dimensions of the cylinder are. Okay, and the formula is, I'm going to give you two formulas, but they're really the same thing. So the formula is the area of a base times the height of the cylinder. Okay? If you were reading a math book, they would write the formula like this. For area of a base, they would denote that with a capital B, just like with prisms. Capital B stands for area of a base, and they would denote the height of the cylinder as lowercase h. Okay? And to take it even a step further, if B stands for the area of the base, and the bases will always be circles, to find the area of a circle, remember, you go pi, you multiply it by the radius squared, and then that's how you would find the area of the base, and then you would multiply it by the height of the cylinder. So if you really were looking at a mathematical book, they would tell you that the formula to find volume, V, volume of a cylinder, is pi times r squared times h. Where did pi times r squared come from? That's the formula you use to find the area of the base. Why did we use pi times r squared to find the area of the base? Well, because the base is a circle, and that's the formula you use to find the area of the circle. And where did h come from? Remember, h stands for the height of the cylinder. So if you're one of those people who like to commit formulas to memory, I would strongly suggest that the pi times r squared times h formula is the formula that you commit to memory, that you use to find volume of a cylinder. Okay, so let's do a couple examples of finding volume of cylinders. Let's do two examples here. So cylinders typically are all drawn more or less in the same manner. That you can only vary them so much. I guess you could lean them over on their sides if you wanted to. So here we have this cylinder right here, and then I'm going to give you some measurements. So up at this top circle right here, I'm going to put a point right in what would be the middle of the top circle, And then I'm going to draw a line segment going from the middle to the edge of the circle. So it's right on the circle. And let's go ahead and let's make this 3 inches. And then right along the side here, let's make this 11 inches. Okay, and we're going to find the volume of this cylinder. Okay, so how do we find volume of a cylinder? We're going to use the formula pi times r squared. What does r stand for? It's the radius squared times the height. So pi r squared h. That's how a lot of people say it. Then that means pi times the radius squared times h. Okay? So pi we're just going to leave as the symbol pi, even though we know that it's a numerical value, but we're just going to leave it as the symbol pi. Now, what's the radius? Well, if you notice, the radius is the radius of the circle, either one of these circles right here. Okay? And that one doesn't have a radius clearly marked, but that one has a radius clearly marked, and the radius is 3. So we're going to go pi times 3 squared, and then we're going to multiply it by the height, and remember h stands for the height of the cylinder. The height is any segment that connects the two bases, and the bases are the circles. So that'd be 11. Okay, and then we're just going to work this out, and that would be the volume. So let's leave pi as the pi symbol for now. Then 3 to the second power is 9. Okay, we have to do the order of operations, so we have to deal with the exponents first, and then times 11. Now, this right here, all I have is multiplying, so I'm going to multiply it out. So I know that 9 times 11 is 99, and I know that 99 times pi can be represented as 99 pi. Okay? And if you leave your answer just like 99 pi, that is a perfectly acceptable answer. Okay, so if somebody said, hey, what's the volume of this cylinder? And if you said 99 pi, then you would be correct. All right, now, once again, how did I get that? Well, notice, basically what I did was I multiplied pi, then I multiplied it by 3, and then, now let's put in the measurements though. So I multiplied it by 3 inches, and then squared, and then I multiplied that by 11 inches. So because when I say 99 pi, I have to know what are my units, okay? So that would be pi. This would be 9 inches squared times 11 inches squared. So total, how many inches do I have? I have inches cubed. So my answer would be 99 pi inches cubed. That right there would be the volume of this cylinder. Okay, now if you multiplied it out and you actually put in the numerical value for pi, and remember pi, although we don't know what it's equal to, it's approximately equal to 3.14, and then a whole bunch of numbers after that. And then as a matter of fact, the numbers after that would be like 15926, 15926, and then a whole bunch of numbers after that. But if we multiplied this out, we would get a decimal for this, and it would be about 311 point, and I'll go ahead and carry it out to the thousand spot, so 0.17 inches cubed. Okay, so the question is always, hey, which way, Mr. Trutna, do you want me to write my answer? Well, this answer right here is in terms of pi. So if you're doing a problem and the problem specifically says find the volume in terms of pi, then you would write the answer like this. In terms of pi means don't multiply pi out as some decimal. Okay? This answer right here would be the decimal equivalent of pi, or decimal equivalent. Okay? And so if you're ever finding volume of a cylinder and it says something like round your answer to the nearest thousandths, that means they want you to multiply pi out times that number and then round it to whatever place value that you are told to do. Okay? All right, let's do one more to make sure that we understand how to do this. And on this one, I'm going to go ahead and draw a cylinder like it fell down. So this cylinder is lying on the ground. I guess we could look at it this way. Just so you see a different perspective of the way that a cylinder possibly, I should have made that dashed. Oh well. And then we have that right there. Okay, so this would be a cylinder that has, I guess, say, fallen over. Let's go ahead and put a point right there in the middle of the circle. And to mix it up a little bit, I'm going to draw a line going through the point that ends up on both sides of the circle. And then I'm going to, let's go ahead and make that 10 feet. And right along this segment right here, let's go ahead and make that 14 feet. Okay, so to find the volume of this cylinder, the formula that we're going to use is we're going to go pi, then we're going to multiply it by the radius squared, then we're going to multiply it by h, and remember the lowercase h stands for the height of the cylinder. Okay, so here's my two bases right here, the two circles. Now, here's where you have to be careful on this problem. So to find the volume, I'm going to leave pi as pi. Now, I need to find the radius. So the question is, does that 10 represent just from the center to one side of the circle, i.e. the radius, or does the 10 represent the entire part across? Okay, when it's drawn like this and you're given a line segment like this, that means that that 10 does not represent the radius, it represents the diameter. Okay, so in this case, the diameter is equal to 10 feet, which means the radius is always half of the diameter, so the radius would be 5. So for r in the formula for radius, we need to substitute a 5. Don't forget the second power times, and then remember the height is any line segment that connects the two circles. So that line segment would be a height, that line segment would be a height. So the height is 14. And then to work this out, I'm going to follow the order of operations. Do the exponent first. 5 to the second power is 25. So then we're going to have pi times 25 times 14. And then I'm going to multiply the 25 times the 14 together. I'm not going to multiply the pi yet. So 25 times 14 is 350. So 350 pi. You could write your answer like that. Okay, and then don't forget the units. So my units are feet, and it's always going to be feet cubed. So the volume of this cylinder would be 350 cubic feet. Now remember, this right here is expressing the answer in terms of pi. Okay, so if you were doing this problem and the directions specifically said express your answer in terms of pi, this would be how you would write it. Or if the problem said what is the volume of the shape to the nearest hundredth, okay, to the nearest hundredth, then you'd get out a calculator and you would multiply 350 times pi. And you could use 3.14 for pi if you wanted to, or you could use the pi symbol on your calculator, it doesn't matter. But you would get 1099 point, and if we're rounding to the hundredths, that means we're rounding to the second decimal place, 0.56 cubic feet. Both of these are virtually the same answer. Okay, both of these are the volume of this cylinder. However, the 350 pi is actually a little bit more accurate than the 1099.56. But either way, that's how you would find volume for a cylinder.